So next we'll take the nested try blocks, right? So just like multiple catch blocks, we can also have multiple try blocks. Okay, these try blocks may be written independently, or we can nest the try blocks within each other. That is, keep one try block within another try block. Okay, that is called as a nesting. So whenever we are going to use a word called as a nesting, right, it means that calling one more inside the another of the same is called as a nesting. Say for example, if you take a switch statement, right? So when you are going to call a one more switch statement inside the another switch, then we get to call it as a nesting of switch statement. Right? When you are going to call a if else in the another if else statement, then we call it as a nested if else. Okay. Now similarly, when we are going to call one more try block inside the another, we call it as the nesting of a try blocks. Okay. These try blocks may be written independently, or we can nest the try blocks within each other. That is, keep one try block within another try block. The program structure for nested try statement will be like this. Say, try. You are going to write the statements of that try, and again inside the try, see, we are not close to the main try. Inside that try, we are calling the one more try, and that will have the catch. This try will have the catch. Okay, and the main try will have a catch. Okay, because when you are going to use a try block, that is going to throw the exception. To handle that exceptions, you are going to use a catch. Catch blocks is defined to catch the exception, right? And this is the inner try and the catch block, which is called inside the another try catch. So for this try, here is a catch block, right? This is a main catch block, and your try statement is going to end here, main. So the following example in which you are accepting two numbers from the command line. After that, the command line arguments which are in the string format are converted to integers. If the numbers were not received properly in a number format, then during the conversion, a number format exception is raised. Otherwise, the control goes to the next try block. It goes to the next try block. Inside the second try block, the first number is divided by the second number. And during the calculation, if there is any arithmetic error, it is caught by the inner catch block. That is the reason why we need to define the inner catch block, because the inner try block is going to throw the exceptions that they should be handled by the inner catch block itself. Okay, and that exception is going to be handled by this particular inner catch block. Okay, so we'll take that example. For example, we'll take some simple example of the nested try block. See, static my main program. Inside the main program only, we can write these try blocks, try catch blocks. Okay, try in beginning of that try block, and we are defining the argument 0 and argument 1. Okay, that is the integer. It is a class name, and you are declaring quotient is equal to 0. Okay, and quotient is equal to a by b. So okay, we are inputting some value for a and b. So what happens is it is going to divide the a and b value, and it is going to store it in the quotient. Initially quotient is 0. Suppose it doesn't get any value, it will be 0. Okay, by default. Now when you are going to divide and a and b, you will get some value, and that quotient value you are going to print it here. Okay, so if the b value you are supplied is a 0, for example, now what happens? Arithmetic exception raised. Now this arithmetic expression raised, and it is going to give the error message, is just divide by 0. So because b that divide by 0 is not defined in our mathematics, which is an infinite value. I cannot imagine what will be the value of that infinity. Okay, that is why you are going to since that is not defined, we are going to give we are going to display the message divide by 0. Okay, suppose where number format does not match. Okay, I am going to give some other value. That time what happens, this second exception is going to be handled. That is a incorrect argument type. So we are given an integer type, but we are trying to give a some other data type, which is not a which is invalid. So that is a that exception is going to be caught if the uh, A and B value numbers are not proper format. The output of the program is if the arguments are entered properly in the command prompt, like to 246, okay, then you will get the answer as a 4. If the argument contains a string, then the number. So here 24A incorrect argument type, because you should not give them the same number format. I cannot take A for division. Okay, so this is how the exceptions are going to be handled with the multiple try block. Okay, where we are going to get the answers. Exceptions are captured and they have been thrown to the try block. In turn, the try block is going to find the. We are going to catch block. In turn, it sends that to the catch block. In turn, the catch block is going to handle that kind of errors in the program. Okay, the output will be. So see here, this is the incorrect type of the argument because A is not a proper type. So this is a try to block 4 and 6. Okay, so 4 divided by 6. 4 is A, B is 6. Okay, when you are dividing 6, we cannot divide 4. So that's why 6 zeros are 0. Remainder will be 4. So this is I cannot divide 4 with the A value. And this one is divided by 0. 4 divided by 0. A is 4, B is 0. So it is divided by 0. You cannot handle that 0. That is not defined. So exception caught. So throw keyword is used to throw the exception explicitly. Only object of the throwable class or its subclass can be thrown. Okay. So here thrown is a keyword. Throw is a keyword which we are going to use it in the exception handling mechanism. So when we are going to use this throw keyword is only the object of the throwable class or it is a subclass can be thrown. Program execution stops and encountering the throw statement and closest catch statement is checked for matching the type of the exception, which is going to very nearer to that particular exception handling mechanism. Okay, so and the closest catch statement is checked for matching type of the execution exception. Say syntax will be throw keyword and throwable instance. We have to specify what kind of variables we are throwing. Okay, so we'll do some examples. So creating the instance of the throwable class, there are two possible ways to get an instance of the class throwable: using a parameter in the catch block, creating the instance with a new operator. Okay, using a parameter in the catch block, we have to use a parameter in the catch block and we have to create an instance with a new operator. So new is the operator which we know that it is going to allocate the memory dynamically during the program execution, whether it is an object or it is an instance variable. Okay, new null pointer exception. This is a program name we are given. This construct an instance of null pointer exception with the name is equal to test. Okay, so this is an exception which is created using the new operator, right? So here new keyword we are using. Null pointer exception is the name of the exception, and for what it is a for the file. Okay, with the name test. We'll illustrate how this example illustrate a demonstrating of the throw keyword. Say class test static void avg try throw new arithmetic expression demo, right? So this is an example which is going to demonstrate the handling of the arithmetic expression. Catch arithmetic exception E system out dot println exception caught. Okay, so catch block catches the arithmetic exception and send the message exception caught. Okay, then come to the main program. We are going to give the avg, that is a function. Okay, avg is a static function. In the above example, that avg method throw an instance of arithmetic expression which is successfully handled using the catch statement. Exception is caught and that number is sorry. And there is another keyword called as a throws, right? Throw keyword and throws keyword. There are two. Any method capable of causing exception must list all the exception possibly during its execution, so that anyone calling that method gets a prior knowledge about which exception to handle. A method can do so by using the throws keyword. Say throw and the throws. Say that is a different keyword. Okay. So here this throws keyword is capable of causing exceptions, list of all the exceptions possible during its execution. We can specify the all the possible list of exceptions, not only one exception, right? More than one exception. Okay, so that anyone calling that method gets prior knowledge about which exceptions are to handle. A method can do so by using the throws keyword. So using you can use this throws keyword in the in this block. Okay, throws list of exceptions will be present in the throws. So you know that throw is the singular, throws is a plural. When you have number of exceptions, that is a list of exceptions, we are going to use a keyword called as a throws. Okay. Okay, next is the so if it is necessary for all exceptions except the exceptions of type error and runtime exception or any of their subclass. So we'll take example how to demonstrate the throws keyword. So we'll take static void check throws arithmetic exception. So inside check function arithmetic expression demo. Okay. So public static void, we call a function called as a check, right? So which is going to find the arithmetic expression which are caught. Okay. So if the exception occurs in the check method, right, that catch block is going to catch us the exception and it is going to print that particular exception is caught from this arithmetic exception. Okay. So So another keyword which final keyword we already studied, and now this is finally keyword. The finally clause is written with a try catch statement. It is guaranteed to be executed after catch block or before the method quits. I told no. So by default, when none of the case does not match with the catch blocks, right? So by default, it goes to the finally key method. Okay, which is going to be executed before after the catch block or before the closing of the program. Okay. If why it is written after the catch block finally method is because when none of the catch does not match, then only it has to jump to the finally method. That is the reason why it has been defined after the catch blocks, but before its quitting of the program or before the method quits. Okay. So finally is a keyword which we are going to use to represent the final execution of the exceptions. Okay, now we'll write the exam syntax of this finally. See that finally keyword method should be written only after the the catch block or before the method quits. Okay. Now try, then the statements which we are writing. Okay. We are going to write the statements here. And the catch, again, exception handling mechanisms. The catch block and catches the exceptions and write the statements. See, after the catch block only we are defining the finally keyword. Okay, we are using the finally keyword. If this try block when throws exception, when this catch block does not match with that exception, it is come to the finally block and executes the statements by default. So take a look at the following example which has a catch and finally block. The catch block catches the arithmetic expression which occurs for arithmetic error like divide by 0. After executing the catch block, the finally is also executed and you get the output of for both the blocks, that is for catch block as well as for the finally block. See now, we'll take this example finally block, how this finally block is going to be executed even in the after the catch block is also executed. See now, a static void division. Okay, this is a method, and try block is having the number 34 and the denominator will be is equal to 0. When number is divided by 0, then it is an arithmetic exception, right? So it is going to get, it handles that error, it is a divide by 0. Okay, when it is a divide by 0, then even though you are already this exception is handled by the catch block, but still your finally block is also going to be executed. So system.out.println in the finally block.